Welcome to Section 4, Data Structures and Algorithms. In this first video, we will look at using list and array everywhere. While list and array are very popular when you need a collection, there are other alternatives you should consider. Let's first look at how list and array works. An array is basically a contiguous segment of memory. That is, the address of each element is actually continuously increasing, and from a memory point of view, each element of array is next to the other element in the memory. You can think of the array as a single block of memory, where the physical address, I should say virtual address, is continuously increasing. Of course, the drawback of using an array is that you have a fixed size of elements. So while creating an array, you have to specify the exact size you're required to fill. Of course, this is a big limitation. Sometimes you don't know the initial size. Sometimes you want to add or remove elements from your array. In that case, it's the second most popular collection in .NET world is System Collection Generic List. Basically, a System Collection Generic List is a wrapper over array. So under the hood, it contains an array, but it doesn't fulfill all elements of this array. It fills up to a point, depending on how you fill it. So it contains an array with some buckets being empty. How does it work? Let's say you're adding a new item to this empty bucket, and then the empty bucket will be filled in this case with item number 1. If you try to add another item, now you have a problem because the array under the hood is already full. So there's no way you can add an element to an array. What happens is the list allocates another array, which is probably twice the size of the original one, and copies all the existing items to the new array, and then adds the newly added item to the end. In this case, this is item number 2. And this goes on. Unless you have filled an entire array, the addition operation is cheap. However, when you fill the array, then the entire buffer must be copied. And similarly, let's say we want to remove item number 1. In that case, item number 1 is removed and number 2 and 3 is copied leftwards. So also this might be an expensive operation depending on what you do. So far you have acknowledged the issues with adding and removing elements. Linked list is a possible solution to make additions and removes faster. I am saying possible solution because inserting or removing an element in a linked list can happen in constant time. It's just replacing a links, but it suffers from another problem, that is the CPU cache. Because CPU cache is 100 times faster than the main memory access. So, in other words, despite the advantages of linked list, that is you are allowed to insert or remove an element easily just by changing the links, array still might be faster. So you have to properly benchmark which one would go better. However, let's say you have millions of elements, you're doing tons of insertions and removals, then probably linked list will beat anything that list and array offers. So in other words, you should consider linked list if you're doing lots of additions and removals and if you have a large elements of collection. Another underused collection is the Hashset. What Hashset does is you add elements and it guarantees the uniqueness of the element. Why we use Hashset? Probably if you need to search if your collection contains an element, Hashset offers the best performance. Basically what Hashset does is when you add an element, it calls this getHashCode method, then applies modulus with its bucket size with that number, and then once it gets another number, it puts it to the relevant bucket. And finally, you should make sure that your getHashCode method should never return a different value. If you return a different value, then you will never find the relevant item. A typical example is here that suppose that you have overridden getHashCode and you are returning a 4, and this is perfectly valid. The problem is that you should try to return as uniformly distributed numbers as possible. Otherwise, your Hashset will in turn becomes a linked list. Still, you should implement the hashcode if necessary that it should never change. Of course, by default, you don't have to override this getHashCode method for typical cases. But in case you need to override in case you change equality of your class, the C# compiler will ask you to override getHashCode as well. In that case, you have to implement it properly. Other than that, if you have not overridden equals, then you don't have to override getHashCode at all. And your Hashset will work fast and it will allow you to find elements in constant time. Basically, if we summarize what you have seen so far, and if we compare the 4 collections, the array, the list, linked list, and Hashset, and in terms of operations, let's say we have an index access. Index access, like in the sense of we are we need to access the fifth element of the array. For the array and the list, that will be very fast. And in the case of linked list, it will be slow because according to implementation, the runtime has to walk through over each nodes. In the case of Hashset, index access is not supported because there is no guarantee that the fifth element will refer to the same item if you call it later. In the case of dictionary, we do not have index access, but instead we use key, and it's very fast as well. Dictionary offers constant time access to the value given the key. By constant time, we refer to number of operations that does not depend on the number of elements. If you're not familiar with the concept of constant time, just assume it is something very fast. The addition operation, of course, in the array is not supported, whereas in the list it is constant time, except when we fill the underlying array, but that happens very rarely. And for linked list, it's just adding another link, and for Hashset and dictionary, it's also relatively fast. Removal is also not supported in the array case, whereas for the list, it will be a little bit slow, because as we have seen, removing an element from the list will cause all the previous elements to be shifted backwards. In the case of linked list, removal is also fast. In the Hashset or dictionary case, removal is also fast because the buckets is based on an array. Those buckets can be very well empty as well. By stability, we refer to the order of the items, such as if adding or removing changes the order of elements. In the array case, well, we can replace an element in the given bucket and that will still keep the order as is. In the list case, we can add and the order of the elements will retain. Linked list is the same as list, but in the case of Hashset and dictionary, in the case of Hashset, it keeps the order as long as you don't remove. However, once you start to remove elements, then the order is undeterministic. In the case of dictionary, also we cannot speak about stability. We have spoken about CPU cache friendliness. Basically, CPU cache is 100 times faster than the main memory access. And for array and a list, we have good results. And perhaps this is the most important reason to use array and the list over other collections. With the linked list, we have a lot of indirection of pointers, so it is not CPU cache friendly. Whereas with Hashset and dictionary, it involves some redirection, so it is, let's say, semi-CPU cache friendly. And lastly, if you look at the contains operation, for array, you have to search each element one by one, and for the list as well, and for linked list as well. But for Hashset and dictionary, we can search if a particular item exists in constant time. So by using this table, you can decide which kind of collection you want to use.